Broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome everyone to the third GO0DMAN webinar in the webinar series. My name is Christopher Gadowski and I work for BOC in Austria. Today's presenter will be José Barbosa from the Polytech Institute of Bragança, and he will give an orientation regarding multi-agent systems in the scope of the GO0DMAN project. Before we get started, let us touch on a few organizational details. So, this webinar is planned to take about 30 minutes, and we'll start with a couple of guidelines. The subsequent content section is where José will talk about the multi-agent systems in respect to use cases of the GO0DMAN project. And we finish with a fade out, if necessary, where any arisen questions may be answered directly. Okay. One important note for this webinar is that all attendees are muted. Regarding all questions, please feel free to use the chat window located in the bottom right-hand corner of your GoToMeeting panel, and we shall take a look at them during the fade-out of the webinar. Another important point is that if you would like to rewatch this webinar on a later date, it is being recorded, and we'll make it available online for on-demand viewing at your convenience. Okay, those were the organizational details. And now I would like to hand the floor over to José to give us the multi-agent systems presentation. José, I'm giving the floor to you.
Thank you so much, Christopher. So let me try to share my screen. Okay, can you see my screen now?
Looks good.
Okay, fantastic. So let's start. Are you only seeing the slides or also this? Also this, I guess.
It looks perfect, José. We just see the slide.
Okay, so welcome to this webinar about multi-agent systems. Why multi-agent system? Because it is one of the technologies that we are using in the GO0DMAN project. In the first webinar, you have heard about what is the GO0DMAN project. In the second, you have heard about the smart inspection tools. And now let's talk a little bit about multi-agent systems and how are we using and developing them in the GO0DMAN project. But first, before we start, what is an agent? This is a question that we should put ourselves. Is it James Bond, the 007 agent? Well, it is an agent, but it's not this type of agent that we are speaking about. Another agent that everybody is familiar with is Agent Smith from Matrix. Well, actually, this could be this type of agent, as you will see, but also, let's not touch into this. This is for another webinar, but it is also not Agent Smith. So, in our concept, what is an agent? An agent is an autonomous component that represents physical or logical objects in the system, capable of act to achieve its goals and to interact with other agents when it does not possess enough knowledge and skills to reach alone its objectives. Basically, the type of agent that we are speaking about is a software piece that is able to, and as the statement mentions, to represent the physical, meaning in this case could be a machine, or a logical object, meaning that could be, for instance, a production order. But it is also very important to mention that we can only name agents, at least from our perspective, if this agent has or displays some sort of characteristics. First, autonomy, which means that the agent should be able to perform autonomously their own decisions. Second, this agent should be able to cooperate with other agents. As the statement mentions, if the agent is not able to achieve by itself its objectives, it must be able to cooperate with other agents in order to achieve the desired goal. And okay, we can go further and we can say that the agent should or can display some sort of reactivity, proactivity, and social capabilities. But at least from our perspective, the agent should be able to display at least the first two characteristics, so autonomy and cooperation. Although that the agents could have some sort of other properties, such as mobility, intelligence, learning, and so on and so forth. So basically, imagine that the agent as a piece of code, a software code, with those characteristics. So if you are able to develop some sort of code that is able to have those characteristics, you can tell yourself that you have developed an agent, a single agent. But what we are trying to say and speak about is multi-agent system. So what it is a multi-agent system? It is a society of agents, so more than one agent. I would say at least two agents that represent the objects of a system, of course, capable of interacting to achieve their individual goals. So what we are trying to speak about here is multi-agent system. So it is a system with more than one agent. A single agent is not a multi-agent system. If you remember from the other webinars, this is a representation or the generic representation of the Goodman architecture. Where are the agents? So the agents are on that rectangle there. So on below you have the smart inspection tools that you have already heard about, and on top you have these data analytics and knowledge management tools that you will heard about in the next webinars. So agents and the way that we represent the agents are in that middle layer, and I will try to explain a little bit more about it. So in short, we have developed 4 types of agents, namely the resource agent, where you can see these red smiles on below. Then we have the product agent, then we have the product types agent or the PTA, and then we have the independent meta agent. All of these agents have a reason of existence. They have some sort of interaction. They have some sort of responsibilities. And I will try to explain them in short. Since we have an agent, and an agent is nothing more, nothing less than a piece of code, we have developed this internal architecture of the Goodman agent. So the agent is able to have some sort of modules in order for him to be able to interact with the physical part. Remember that the agent can represent a physical entity. So of course, we need to have some sort of mechanism, some sort of approaches that allows the agent to interact with the physical world. Of course, that when we have a society of agents, we have some sort of, we need to have a communication model, meaning that the agent needs to communicate with other agents. In fact, imagine an agent as being a person. A person, we ourselves, we are autonomous, more or less, okay, but we are autonomous. When we act in a society, we need to cooperate, we need to talk with each one another. So as a society, we could be seen as a multi-agent system. And then at the heart of the agent, we have some sort of blocks that are able to control the agent, to allow the agent to monitor the external world, having, of course, an internal database for him to store data that can be processed later on. And since we are addressing zero-defect manufacturing approach with multi-stage, we need to have some sort of zero-defect mechanisms that will allow the agent to, on behalf of the entities of the system, to achieve this zero-defect. And we have this book here where the rules are appearing, and you will understand this at the end of the talk, that we are using rules for the agents to process. So having all of these, how do we design the agent itself? So, and I will give a little bit of a theory behind the design of the agent. So we tend to use these UML class diagrams in order for us to design the main functions, the main behaviors of the agent. As you can see from here, here we have the 4 types of agents. So the resource agent, the product type agent, the product agent, and the independent meta agent. Each one of them has its own particularity, responsibilities, particularity methods that they need to perform. but all of them inherit from this Goodman agent, the basic stuff. So the skeleton of the agent is here. So this is only a way for us to represent and start to design the agent and how we will later on implement the agent. To give a little bit of context, I speak about 4 types of agent. So let's try to make in our mind the picture of where are the agents position themselves in the production world. So the product type agent, or PTA, represents the product that can be produced within the factory plant. And in short, we will have one agent for each product model. I will give an example. One of the use cases in the Goodman project is Volkswagen Auto Europa. They produce cars. One of the models that we are using in the project is this T-Roc. So the T-Roc is the type of car. So this type of car is represented in the multi-agent system by one agent. If we're going to address 2 types of cars, let's say the Charan, then we would have 2 PTAs. And the same could apply for the other use cases. So for instance, for electrolux, we have 1 type of oven. And so we have 1 PTA. If we have more than product types, so let's say another type of oven, we will have another PTA. So the PTA will be as many as types of products existing in the system. The product agent by itself will manage the production of product instances, and this is very important. So going back to the Volkswagen example, so the T-Roc, let's assume that we are producing at this right moment, at this right time, 100 cars. Means that we will have 1 agent for each one of these 100 cars. So the product agent is the agent responsible to execute, to manage the production of the instance of the car. Of course, that we can have more or less PAs. It depends on the number of products that we will be, or that they exist right now at the system. For instance, in the Zanini use case, that is another use case of the product, we are not talking about this discrete manufacturing. We are speaking about batch production. In this case, the PA is representing the batch of products. Resource agent represents the resource disposal along the production line. And again, here we will have 1 agent for each one of the resources. So let's assume that we have 1 tool that is able to put some bolts and nuts in the car. We will have 1 resource agent to process it. Let's assume now that we have 1 quality inspection station that is performing some sort of measurement to see if the product was well produced or not. We will have another resource agent in order to represent. So if a given production station, if a given production line has, let's say, 200 stations to produce a given product, we will have 200 resource stations, each one representing 1 resource on the multi-stage process. And then we have this independent meta agent that is acting at the strategic level to provide some global optimization. Of course, that the system can work without them, but we will compromise the optimization. Also, in this Goodman project, IMA has also an important role that is making the bridge between this OT and IT world in order for us to increase the security of the system. So some of the main, and let's go brief into this, some of the main functions of the PTA. The PTA is like the father of the product agent. So in every time that an instance of the product appears in the production line, it is the responsibility of the PTA to launch it, but also to monitor the ongoing production of products. And here, just to give one example, while we are designing agents, we need to, or it is a good practice, at least in our opinion, to try to see if the behavior, the roles, everything that we are trying to implement in a given agent will work according with plan or not. Another mathematical and software tool that can be used for us to assess this and to verify if the agent is being well designed or not is, for instance, using this pattern net approach. With pattern nets, we can see if, for instance, if the agent will reach a state that cannot progress from there. So we are trying to avoid design errors at the design phase using this pattern net approach. And we have done this for every agent. If you want to read more about it, we have some deliverables that will speak about it. The product agent. The product agent, again, is able, one of the main functions to collect and storage the production data related to this given instance of the product, but also to adapt the process and the inspection parameters according, for instance, to the previous stations. So let's assume that in station number 10, the product is there to be processed, but based on the previous 9, we know that I don't need to perform some sort of test, or I need to adjust the torque, or I need to make this and that. So product agent, based on the historic of production, can do this adjustment and can inform, for this resource agent, that this would be the best way for him to be processed. The resource agent, again, collecting and storage of data. But now it's not data only for a given product, but it's data for all the products that have passed into the resource agent, on that particular resource agent. So it is different type of data, different type of analysis that we can make on top of this data. And here, since we have the resource agent, and the resource agent is the one that is being responsible to interact with the physical devices, we are trying to use as much as we can the standards that will be industry approved, or that are the ones that, at least from our concern, are the ones that industry will adopt better. And we are speaking about MQTT, for instance, but particularly using OPC way. So OPC way, as everybody knows, is one standard that is being widely adopted by manufacturers, but also the integrators at the production shop floor. So our GO0DMAN agents, particularly the resource agents, are able to speak OPC way, which means that integrating an agent with a physical resource with this respect will be very easy, and to our concern, it will be, let's say, future-proof, because they will be able to use a technology that will be, by sure, adapted in the future. Also, another very important feature of the resource agent is to adapt operations parameter according to the local knowledge. In the first webinar, you heard about this local and global stuff. The resource agent, based on all the products that were processed there, one of its responsibilities is to adjust the parameters. One example, if we have one resource agent representing and managing one quality inspection tool or one smart inspection tool, let's assume that this inspection tool is measuring 10 points. But in the last 1,000 measurements, point number 3 was stable. So one of the optimizations could be, let's not measure this point number 3, because we know that it is already okay. So we are saving time in the process while we are ensuring the quality. And then we have this independent meta agent. So this, let's assume this, I like to call it God in this multi-agent system. So it is aggregating, it is collecting all of this data. And it is managing the subscription of optimization services requested by local agents, meaning product agents and resource agents. And also monitoring the system performance in order to detect some improvement of opportunities. But it is also making a very important role or job in the GO0DMAN project. It is propagating the rules, or propagating the rules generated from the knowledge that is generated from the data analytics. I will explain this in a little bit, to the local agent. And so this is propagating the correct rules to the correct agent to be processed in real time. So what we have a multi-agent system. Okay, we have PAs, I already explained, resource agents, PTAs, and then we have this independent meta agent that is acting also as the gateway between this OT and this IT world. And this data, so all of these agents are exchanging data, are exchanging information, and IMA is like the gateway to the external world. So it is sending and receiving data from this big data analysis tool, but it is also sending data and receiving data from this knowledge management tool. Since we are speaking with each other, since we are exchanging information, another design phase of the agent is the interaction patterns, where we try as far as we can and as deep and as descriptive as we wish to design the way that agents will need to send data. One example, if resource agent receives data from the smart inspection tool, one of the jobs that he has is to send data to the product agent or to independent meta agent. So this interaction pattern, we need to design it as many as we can in order for us, again, at the design phase, we are debugging some errors. But since we are here speaking in English, the agents must speak the same language, and they do. But they need to have the same representation of the data, the same representation of the knowledge. How can we do this? And for that, and just to give an overview, we have designed a data model that is representing the types of information that the agents can use in order to exchange data among themselves. And this is not only being used by the agents, this is being used by the inspection tools, and this is being used by the big data tool and the data and the knowledge management tool, meaning that everybody is speaking the same language in the same way, which makes easier and transparent the inclusion or the removal of other blocks if everybody speaks the same language. So this is the foundation for designing this multi-agent system or the Goodman multi-agent system. But then we need to go further. Now everybody speaks about Industry 4.0. Is Goodman approach aligned or not with Industry 4.0? We have done some research. And from the research we have done, we can say that the Goodman approach, the Goodman architecture is pretty much aligned, but it is being done and developed in this Industry 4.0 context, which means that, okay, we are not making some sort of out of the blue sky stuff, but we are making concrete stuff based on foundations and based on the trends that everybody is using. So now let's speak about a little bit about more concrete stuff. So how does the agent, for instance, collect data from the physical world? And again, I'm going back to OPC-UA. So OPC-UA is a communication protocol that many vendors, many manufacturers are using. And this was the communication protocol that we use and decide to use in the Goodman project for the agents to access the physical devices, particularly the tools that are being developed from scratch for the Goodman, the ones that you have heard about in webinar 2. So basically, in very short, and I will explain this later with this global picture again, the agent is exchanging data between the inspection tools using OPC-UA, on which the data format that we are using is the one you've seen before, so the Goodman data model. So if we want to use or deploy 10 inspection tools, no problem. We are speaking OPC-UA, we are using the same data model. It's only a matter of launching or instantiating 10 resource agents. So, and this is another added value from agents. You develop it once and you can deploy it as many times as you can. You don't need to code again. So if we have 10 stations in a production line, we don't need to develop 10 resource agents. We need to develop one source agent, and then we need to instantiate. And this means launching them, so putting them into life, let's say, 10 times. Of course, that we need to parameterize which one of the stations, but in terms of effort of developing of software coding, we only done this once. So we already know how the agent receives data from the physical world. But what about sending the data to the knowledge management and to the data analytics tool? Well, again, here we are using standards. We are using REST calls in order to send data to the data analytics and to the knowledge management. So every time that a new data is generated in the system, IMA is responsible to propagate this data to both the data analytics block and the knowledge management block. Again, using a standard, REST, but using the data format JSON, let's say, using the format defined in the GO0DMAN data model. So having all of these, how do we develop agents? Well, agents, at least from us, since we are from academia, we are developing agents for many, many years now, and we are used to use Jade framework. Jade stands from Java development of agents. And since we are talking about Java, means that pretty much every plugin, every add-on we can put in a Java developer or normal Java development code, we can put it in Jade. This is how we are putting the agents to speak REST, to speak OPC-UA, MQTT, and so on and so forth. So it is easy for us to integrate pretty much every technology available. We are using the Maven project, which simplifies greatly the development of the project, and also Git repositories, let's say, not to lose the program. Agents parameterization, so meaning going back to the example of the 10 resources. The agent parameterization is compliant with the GO0DMAN data model, which means that if I want to instantiate 10 resource agents, I develop one piece of code, and I instantiate it 10 times, meaning that I need to have 10 pieces of parameterization, each one for each one of the stations. What type of parameters are we speaking about? Let's say the IP address of the OPC-UA server where the data is, because if we have 10 resources speaking about OPC-UA, then we might have 10 IPs, or we can have one IP and 10 items different in order for us to have access to the data. So we are speaking about this type of parameterization. So let's suppose that the URI for the knowledge management changes. We are speaking also that the agent is listening to here. So we don't need to stop the agent and launch the agent again. We only need to point the agent to the new URI. MQTT and OPC-UA are currently supported and fully implemented into the agents, meaning that every type of topic coming out of using either MQTT or OPC-UA, the agents can speak. The GO0DMAN data model was also implemented using a very well accepted standard, which is Automation ML. And for the internal storage of the multi-agent system, we are using PostgreSQL storage. Now, before we ending, let's go and have again the full cycle here and the full picture. And let's try to make a different thing. Let's see if I can do. So how is the full cycle? I hope you are seeing this. So data is coming. So a new product arrives, and the inspection tool tells to the resource agent that the new data is arriving. The resource agent performs local optimization, saying which parameters should the inspection tool, let's say, read or execute. These are sent back to the inspection tool, which performs the measurement. then the results are propagated back to the resource agent. The resource agent picks this and passes them to the rules that this agent might have. What type of rules are we considering? Let's assume that I want to measure the electrical current of the DC motor. If the current is higher than 2 amperes, then this motor has a defect. So the rule could be if current above 2, test false. So we can say that we are speaking about this type of rules, or even more complex rules. Once this data has been assessed, let's say the resource agent sends the data to 2 entities, namely to the product agent that is responsible to manage the product that is being produced right here, and to the independent meta agent. And as you can see, every agent in the system are doing the same thing as here. But now we are speaking about a multi-stage, right? So where does this multi-stage could appear, for instance, or as an example in the multi-agent system? At the product agent level. So the product agent level has data from this stage, from this stage, from this stage. Now we can have more complex rules running here. So we can have complex rules correlating data from this station, and from this station. While in this resource agent, we are only processing data related to this particular station here, the product agent can process data in different stages. So the multi-stage could appear here. So we are sending the data here. What IMA do? IMA sends the data to the data analytics and sends the data to the knowledge management. The data analytics is processing the data. So it's, for instance, analyzing trends, and something is wrong here. But at this phase, the data analytics does not have the knowledge. It does not know what does this mean. So it sends this data to an expert that uses the knowledge management to say, aha, I have already seen the problem, so I am happy. Sorry for my bad drawing. I see the problem. Now I will create new knowledge. And this new knowledge is propagated down to the agent in the form of rules. And we have here this block that is converting this knowledge representation into Goodman compliant rules. And then IMA, or a bunch of them, are propagating down the rules for the given agent. And now the agents are going to process the new data, the new product, the new resources, based on this new knowledge, based on these new rules. And this is a continuous process about collecting data, processing data locally, processing data at less locally, more global, processing data at the global, but also using these high-level tools, high-level components that allows us to process huge amount of data, and from this data, generate knowledge in order to put the agent running over and over and over again. So since an agent is a piece of software, I'm going to show you, just to end, a screenshot of our agent. So our agent is not 007, it's not Agent Smith. As you can see, it's a bunch of lines that are here processing data for 3 use cases: for Electrolux, for Volkswagen Auto Europa, and for Zanini. In terms of effort of deployment, we only developed 4 types of agents, and we are deploying them in 3 different facilities: Italy, Poland, Portugal, with different constraints: no cloud, with cloud, internally. But we have only developed 4 types of agents and instantiate them as many times as we can or as we need. So I hope that you now know a little bit more about agents, and at least you know that we are not speaking about James Bond. And I don't know if you have some more questions.
Thanks a lot, Jose. Yeah, for that interesting presentation regarding multi-agent systems in the scope of the GO0DMAN project. I see that we do not have any questions at this time, so I'll just want to quickly share my screen so that everyone sees the contact. So if you have any questions, please feel free to contact us. And we are available on the homepage, the Innovation Shop, or by email. This will conclude today's webinar. Thanks for your attention, and we wish you a pleasant afternoon.